Okay, this is the final problem. A lot of people had trouble with this one. Question 18 on the pre-cal, I can't even speak, pre-AP Algebra 2 test, graphing quadratic functions. And this was number 18. It was the last one in section 4.1 and 4.2. And what we were supposed to do was carefully graph the equation and then approximate the area under the parabola and above the x-axis. And the implication was to do it the way we had done it in one of the challenge problems in the earlier sections. It also said make sure your rectangles are 1 unit wide so it's easier to calculate. So one of the things to realize is we need to know the area of a rectangle. Formula is base times height. You can use length times width, but it's going to make more sense to do base times height. And one of the things was suggested, make that a 1. So then you have 1 times h. And it turns out that your area of every rectangle is really just h. Now the units aren't h, the units are squared. Okay? They're usually squared, but it's still h is the number. So that's going to be very useful for us, and we're going to need to use a calculator and look at the table. So the first thing is to graph this thing, and so we need to graph this well. Well, this is written in intercept form, so I know x equals -1 is one intercept, and the other one is 5. So I want to graph -1, 0, and 5, 0. So 5 zeros right here, and 1 0, -1 zeros right there. Okay. The other thing we need is we need a vertex, and so we can just take an average of here. If you want the x of the vertex, we can go right here. The vertex is going to be well, actually, let me erase that. I'm just going to calculate the average. The x of the vertex, which is also the axis of symmetry, is -1 plus 5 divided by 2, which is 4 divided by 2, so x equals 2. So somewhere along x equals 2, right along here, try to just do dots, right along here is our axis of symmetry, and so we now know we can put 2 in there. So let's figure out what the y value is when you put 2 in there. So y equals -4/3 times 2 plus 1 times 2 minus 5. Okay, well this is 3, this is -3. Okay, it turns out if you have -4/3 times 3 times -3, this 3 can cancel out that 3. And then you'll have -4 times -3, which is +12. So the vertex was 2, 12. Okay, so I'm going to graph that here, and I don't think I left enough room for it, so I'm going to have to slide my axis down here. I'm going to have to, that's a pain, so let me get the eraser. Just have to change the x-axis, and I'll just draw one in here. I'll put it maybe down about right here. So there's my x-axis. Now I can go up 12. So there's 2, there's 12. You see I kind of cheated. I knew it was going to go right there. Okay, so there it is there. I also know my zeros. Remember, I got my zeros right here. So I've graphed this right now. My zeros, I got to go to -1 again. And I got to go to 5. And it'd be nice if I got some points in between. So let's just I don't know what number you want to put in there. Let's try 1. Let's try 1. So maybe 1. I don't know what you want to try, but or we can try 0. Let's try 0. Let's try x equals 0. Okay, because that should get fairly easy numbers to calculate, and so we get y equals -4/3, 0 plus 1, 0 minus 5. So that's y equals -4/3, 1 times -5. Well, that's y equals 20 over 3, which is approximately 3 times 7 is 21, so this must be about 6 2/3. So if it was 3 times 7, it would be 21 exactly, but it's 1/3 too low, so 6 2/3 when x is 0. So 6 2/3, well, here's 2, here's 4, here's 6, so it's just a little bit higher, about right there. Whoops. Having trouble getting this to draw it. It's about somewhere under there, right there. Okay, so I'm going to do the same thing under here. Remember, this is just approximate. Okay, so now I'm going to connect those. Got to go up to here, come back down through there. And that was horribly done. So let me do that again. Do it from the vertex. There's that part there. And that part there. Looks more like a triangle. I can't draw very well tonight. That's because I put it in the wrong spot. Doesn't make sense to put it there. It's got to be 2 away. It's got to go right over here. Right there. So I'm going to go. And now I can make it look the better shape. So it looks something like that. And I want the area that is, I'm going to shade that with a really light yellow. I want this area right in here. Okay, I want all this area. I want to estimate it. Now if we had calculus, we could take the integral and we get the exact value. Okay, so that's the area I want in there between the x-axis and the parabola. So now we need to do the rectangles. So I'm going to get rid of a lot of this stuff. If you got the graph, I gave you 1 out of 2. Okay? Okay, so I had paused it and cleaned it up a bit. We got that graph there. We need to get the rectangles, and this is where people had trouble. Where do you draw the rectangles? They were drawing them all over the place. But what we said is we want them to have a width of 1. So 1 unit would be like from here to here. Okay? And how high do we go? Well, we're going to go until we hit up here. Well, I hit there, so I'm going to have a rectangle right there. It's not drawn very well, I'm sorry. It's going to be that right there. That rectangle I need to find the area of. Okay, well, how do I find the area of that? Well, I know the base is 1. Okay, and I just need its height. Now, how do I get the height of this thing? How do I get the height? How do I get that height? It's just under, it looks just above 4, not quite 5. How do I get that? Well, I can plug it into the function. So I'm going to go back and I'm going to put this function in the calculator. The function was y equals negative 4/3 x plus 1 x minus 5. I'm going to put that in my graphing calculator and look at the table. So you can pause right now and do that, and then you can come back. So I'm back here, and I just put that in my calculator. I put this into y1 on my calculator, and then I went second graph, which gives me the table. And the thing is, I'm at, in this particular case, I'm at x equals negative 0.5 or negative a half. I want to see what that is on the table, but my table isn't set up for that. So if you press second window, you can tell it to set the table. So it says the change in TBL. You can set that to 0.5. Instead of counting by ones, which is standard, you can set it to 0.5. And now we can see what the values are every half a unit. And so I'm going to get, remember, my height of the rectangle is the value f of negative 0.5. That's my height. Okay? That's what I want. So I'm going to need a table here, and then okay, so let's do this. X, f of x. I'm going to table of values here. Okay, so I need negative 0.5. And when I look on my calculator, second graph, and look at the table, it says that negative 0.5 had 3.6667. So that's really 3 2/3. So now I know that H is 3 2/3, but I have to multiply it by 1 because that's the base of it. And so my area is 3 2/3. So it turns out that this here is the area of the red rectangle. So I'm going to do the same thing with a different color rectangle for the next one. So now I'm going to go over, I'll do it in green here. I'm going to go over to the next halfway point, which is right there. And I'm going to go up. I'm going to make another rectangle go all the way up here. And it hits right there. So there's my rectangle. I need to find that rectangle. I need to find its area. Now you'll notice here, you can't see it very well, but there's a chunk of area right here that we didn't count for, but we had too much of it right there. Same thing's going to happen here. We're going to have too much area right there, and then we'll have a chunk that's going to be open when I do the next rectangle. So how tall is that? Well, I'm at x is 0.5, and I look at my table at 0.5, and that says that it has 9. So my area for this one is 9. So I have a 9, and I have a 3 2/3. So I'll do another rectangle. I'll do this one in purple, and I'm going to go over here to 1.5. Okay, I'm going to go up till I hit this, which is right here. So I want that purple rectangle. Whoops. So I want that rectangle's area. Now I know this is kind of a bad drawing, so bear with me. But now this extra area here is actually being offset by not enough area taken right here. And you also have a little bit of area at the top that you're going to have that you haven't accounted for. So I want to do the purple rectangle. I'm right here. So I'm at 1.5. So I'm going to look on my calculator at 1.5, and it says 11 2/3. 11.67 is 11 2/3. That's my purple area. Okay, and if we keep doing that, this turns out to be purple as well. Okay, we've got one right there. That's purple. Okay, and then we need a green one, and it comes over here, and it turns out to be the same as the other green one. And again, the same problem with overestimating and underestimating, but they kind of cancel out. And then we've got a red one at the very end, which goes right there. We've got that one there. And it turns out the red ones are all the same. They all have the same thing. If you look up the other values here, if you look at 2.5, 2.5 is the other purple one midpoint. That's right there. 2.5, you get 11 2/3. And if you look up 3.5, you get 9. And if you look at 4.5, you get 3 2/3. So really all we have to do is take this and multiply by 2, and we've got the area approximated. And when you do that, the approximate area under the parabola is approximately 48 2/3 units squared. Okay, so that's how you did that one. And it was right out, we practiced it in class out of the challenge problems.